Okay, here we have volumes. So we're gonna look at trying to solve all these problems that's dealing with asking about liters being produced if this many grams of nitrogen is consumed. Now we can use this fancy triangle to help us out, but before we do that, we need an actually balanced equation. So they tell us everything we need to know here. They tell us that we have ammonia being produced. So ammonia is one of those ones that you need to remember, NH3. Alrighty. Ammonium is NH4, which is an ionic charge. So that's why we have NH3. So it's going to produce that. And it also says that nitrogen is in there. So we know nitrogen is N2 in its molecular form. And hydrogen, H2. Now we have to balance. So you go through the regular process of trying to figure out how many to do, but let's look here. We have 2 nitrogen, 1 nitrogen here, so that means we have to have 2. And then 2 times 3 for the hydrogen makes 6. So we need to be 2 times 3 to make 6. Now it's balanced. So now we can actually start filling in information that we know. So we know 28 grams of nitrogen was used. And we want to know the molar mass. Molar mass, nitrogen. This is 1 nitrogen, it's 14. So 2 nitrogens would be 14 times 2. It's 28. Oh, wow, that was nice of them. And then over here, right, this is what we're looking for. Ammonia liters being produced. We want to know liters. So the way we're going to figure out what the liters are is this big hint right here. At 0 degrees Celsius. So we know at 0 degrees, it's standard temperature pressure. They'll either put in the question, STP or 0 degrees, or RTP, which is room temperature and pressure, or 25 degrees. Either way, you know which one to use. So here, we had to use the molar volume. So on STP, we're going to use 22.4. Just means that every gas, no matter what, if it's at 0 degrees Celsius, it's going to be 22.4 liters for every mole of gas. Every gas. It's kind of a fun trick. So now we can solve. And the reason why this works right here is because of the triangle for volume. So we're going to find the volume by multiplying the molar volume, 22.4 liter per mole, by how many moles there are. Okay, that's how we're figuring out how many moles this way. So let's solve 28 divided by 28. There's no number, so we assume it's 1, so divide by 1, times 2, times 22.4, make 44.8 liters. Okay, so now the second part of this question, right? It's still carrying over. So we'll have the N2 plus 3H2 make 2 ammonia. Sorry. So what if we only had 48 liters? dm cubed is another way to write liters of hydrogen. Okay, well, let's write that down. If we had 48, we're just going to change the symbol to liters. So, would we still have excess? Okay, so, way to go about this is to convert it into the product and see how much product 48 liters can make. Okay, oh, and then they're also asking how much money would that make. So we can do double duty right here because we know our original 28 grams was able to make 44.8 liters. So let's go ahead and do this. It says 48 liters. it doesn't say anything about STP versus RTP or any type of temperature. So we can assume it's still talking about the same temperature, because otherwise this number wouldn't be worth anything. So we're going to use our 22.4 still to convert liters into moles. So 22.4 liter per mole. And then coming back out, it's 22.4 liters per mole. Alrighty. So now, it was a lot easier because we didn't have to worry about mass at all. So now, we just type in what we're doing. So as we go towards, we divide. As we go away, we multiply. So 48 divided by 22.4. All right, divide by 3 because there's 3 moles of hydrogen, times 2 because there's 2 moles of ammonia, times 22.4. So we get 32 liters. Okay, that's one part of the problem, right? So now we can see if we just relied on this amount of hydrogen, it would make less ammonia. That's not going to work, right? We wouldn't have excess hydrogen would be the limiting reactant. Okay, because they're still trying to figure out if it's the excess reagent or the limiting reagent. It's limiting because it makes less than the amount of nitrogen that we said we had.